RPM, and in fact this macro is saying that the order RPM at 2000 is in fact the first order. That's the running speed of the machine. And then we're going to go off and run this macro, and we'll look at that in a minute, which is going to run its program one time, its series of commands. So a macro, when we tell it to run, it simply goes through all of its commands and execute them in each of the windows that are designated here. So I can execute any command in any window. And then some of them will have parameters associated with them. For instance, this command here that's running in this macro itself has two parameters. They're called variable 1 and variable 2. Now the command itself says set variable 1 equal to variable 2. That's what this command does. So what it's going to do is set the order RPM equal to 2000. And down here I've specified that. I've said pick a variable called order RPM, and there's a number of variables in this project. Here they are. I've got a list of them here in this pick list. And so that variable called order RPM is going to be set to 2000. Well, where do the variables come from? Those, if I go up into the macro command menu, here is a command called global variables. So I'm going to go ahead and open that, and it says global variable setup. So here it is. Let me make this a little larger. These are variables which any of the macros in MeScope in this project can share. And they can set values, they can test values, there's some logic statements, part of the macros where if the variable is equal to a certain value, then the program can branch to different steps in that macro, or exit, or call another macro. So if you're a programming aficionado or one who is used to writing programs, you can think of each of these macros as a subroutine. That's what programmers call a subroutine. So I can have one macro do some steps and then go off and call a different macro. So think of this command right here, Unbalanced Cases, as going to that window and executing it as a subroutine. And then it will return back to this macro, but there's nothing more to do, so it will finish the execution of this macro. And the whole thing will stop. Or if I go over to this macro here, maybe it's going to continue doing something else. If we go up under the current project, you can see there's quite a few macros in here. Some of them are only a couple lines long, and this one called Unbalanced Cases is quite lengthy. But you can see how we've broken all this processing in MeScope up into a number of smaller programs, if you want to call them that, or subroutines is another word, or simply macros. So you can see I've given them all names here, 2,000, 4,000, 6,000. Those are running speeds of this machine. Archive, that's going to put data into the archive. Baseline, that's going to restore some baseline data. We'll look at that in a minute. And then there are a number of other ones here. Let's look at some of this data here in this project. And then there's one in here called Start Over. So that, if I were going to execute that macro, that's probably where I would execute first. And it's called Start Over, so that should reset everything. Now there's one other issue here, and that is what we call hotkeys. So each of the macros in the list here can be executed by pressing a hotkey. Now, where are the hotkeys? Well, they're right up here on the toolbar, and they're also right here in a command menu called Hotkeys. So if I go here under Press Hotkey, I have defined all of these hotkeys, and you can see the names of them there: first order, second order, third order, balanced, small inboard, small outboard, large inboard, and so forth, all the way down. And here's one called Start Over. Now, if I look up here on the toolbar, all these hotkeys are displayed right up here. So it's very convenient for me to come up here and simply press one of these hotkeys. They will always show up here on the toolbar next to some of the other tools from MeScope that have been placed on the toolbar. But these hotkeys will always show up here, so I can automate this whole use of MeScope in this project by pressing one of these hotkeys. Let's go back here and look at how they were defined. I'm going to go here under Hotkey Setup. So this spreadsheet is where we actually define each hotkey. So if I go up here on my toolbar, I have a command that's edit add. That's a common command that we have in many of the windows where I can add another hotkey. If I press that, you can see it just added another command down here called new hotkey 14. Here's the macro name if I press that hotkey that it's going to execute. And then the machine name, that has something to do with our archival database and how we define machines in the database. Here is an icon where I can pick an icon for the hotkey. So you can see we have a pick list of various icons here. And then I can also give a description. Let me go back and select this hotkey, and I'm going to delete it because I don't need any more hotkeys in here. It says, do you want to delete this selected hotkey? And I'll say yes. The other thing I clean up here, you can see show in console. Only certain keys are going to appear in console that I say yes in this column. If I don't want them in console, which is a separate program that runs on the other side of the database, the archival database, then I limit those hotkeys which are shared with console. We'll come back to that. Over here, I really wanted, the Big Rotor is the machine name for this particular project. Down here I could set this to Big Rotor or to none, and if I put it to none, that means none of these hotkeys will be shared with this particular machine in the archival database. So there's a number of things going on here. I'm going to jump back and forth to explain them, and keep in mind that we have these hotkeys that execute macros. We have an archival database where MeScope can archive data, and then we can look at it with console. Let me just show you a picture of that real quickly. Let's open this up. Okay, so here's a picture of the Big Rotor, what we call the Big Rotor. And it's got a number of accelerometers on it. This is a machine that we have here at Vibrant that we use to test our software and for machinery monitoring applications. We've got a number of accelerometers. You can see there's a couple mounted up here on the bearing blocks. There's some on the base plate. There's one up here on the motor. This is a typical acquisition setup for measuring what we call order-based or ODS data, operating deflection shape data, on a machine like this. Here's another picture of the machine showing you the accelerometers, and then here is a photo model of the machine where we took digital photographs of the machine and built a 3D model, and these photographs actually are attached to the surface of the model. And what we're going to do is simulate unbalanced cases by putting, we have done this, small screws onto either the inboard rotor or the outboard rotor to cause specific unbalanced cases. And then we measure the ODS and compare that with the known ODS of each unbalanced case, and we can use the facts calculation to identify a specific case. So a lot of things going on here. Here's the block diagram of what I was explaining earlier. We have Emiscope running in an unattended fashion in one of these suitcase boxes, acquiring data from a machine, putting the data into an archival database, and then our console software here in various forms, a tablet or a PC or even a phone, where we can do graphical displays of data, we can do trend plots and comparison with warning levels and animated ODSs and so forth. So we'll get into a little bit of all this today, and but the main thing is that macros allow Emiscope to do repetitive things and run in an unattended fashion. Let me go up here and just press this hotkey and show you how all this works. I'm going to press this start over hotkey. So let me press that key. You can see it popped up a macro here. It's executing that macro. It's showing you various macros that it's executing. There's a whole series of them. There's some shape tables, and now we have an animated picture that popped up. So Emiscope did all that under just by pressing that one hotkey called Start Over. So it's put the Emiscope animation into a comparison format. It's got two models of the photo model of the machine. I can either look at it as a photo model, or I can go and simply look at it as a surface model with lights on it. Many times as engineers this is a little clearer for us, but the photo model is also very good for showing your data to the customer, the client, your boss, someone who doesn't understand what this data is all about. The blue cubes and the blue cylinders are indications of where the data is actually being acquired, or where it has been acquired on this machine. You can see they're numbered there. The points, the acquisition points are numbered. It looks like there's 6 of them in this particular case. And we have triaxial data on the bearing blocks and uniaxial down here, at least on a couple of these accelerometers. So if I go back up here to my hotkeys, I've got first order, second order. Let me press one of these hotkeys. Let's press second order and see what it does. That's going to run a different macro, and now I'm looking at second order data. You can see the rotation slowed down a little bit because the machine is actually set up to rotate, or the model is set up to rotate at 2,000 RPM. When I display the first order data, let me go back and press the first order, it actually rotates at the same speed as the sinusoidal dwell animation. So I can look at order-related results that way. How did we set that up to animate? If you go in here, you can see the rotating parts. These are the substructures of this model. Let me drag the rotation over here. You can see rotation, yes. I want to grab the RPM. So this model has been set up so that the rotating parts will rotate at 2,000 RPM. When I'm animating data over here out of a spreadsheet, here's the baseline at 2,000, and again down here, both models are animating with the baseline at 2000 RPM. The rotating parts, there's all the rotating parts. If I select them, you can see that the model has been set up so that the rotating parts will rotate at the same speed. Now, it's not deforming very much, but let's go press some of the other hotkeys here because we're balanced right now. And this little SDI indicator here is telling us that these two shapes are the same. Their shape difference indicator is equal to 1. SDI is very similar to the modal assurance criterion if you're used to using that. What did I do here? I lost my, let me go back and see if I can recover. Lost my little SDI. Oh, here it is. Ended up right in the middle of the model. Let me press another unbalanced case here, small inboard. Now this is going to run a macro. You saw that macro there. And now you see that the model on the left is the balanced case. That's called baseline. The model on the right is over here in this shape table, the small unbalanced or small inboard. You can see the model start to deform, and that unbalance, that's simply the ODS from the running speed out of the spectrum of this data, the Fourier spectrum of this data that was collected at these points. And notice the SDI here. It's dropped down very close to 0. It's telling us numerically that these are different shapes, quite different ODSs. Let me press another button here, small outboard. It's going to run a macro. Go ahead and display it, and now the SDI has dropped to 3%, 0.03. You can see a little more deformation of the right side versus the left side. And again, left side is the balanced machine, right side is a small outboard unbalanced. Let's go by here and let's go all the way out to this one here, which is the worst case. It says both wheels have unbalance at 0 degrees. So we put a little unbalanced screw on both of the rotors and they're both in the same position, unbalanced. So let's just go ahead and press that. Again, that's going to pull up that data, and now you can see that the SDI is 0, and you can see the machine is deforming quite a bit on the outboard bearing block, because that's kind of the most flexible. Here we can go here. Oh wow, well that's a little too busy, so we'll go back here and just look at it from the side, and you can see that everything is flexing, the base is moving. This machine is really out of balance here. So what is causing all this to happen? Well, let's go through and look at some of these macros. Now we looked at the 2000, and let me put that back up. So it is simply setting up two variables called RPM 2000, and it's defining it as a first order, and it's going and executing this macro called Unbalanced Cases. So this one here is going to do all the work of selecting the appropriate data and displaying it in animation. So I'm going to put this one down. It says, do you want to make changes? No. Let's go get the macro that's doing all the work here, right here. And I'm going to make this large so we can look at it. And you can see there's just a bunch of emiscope commands. So this is the one that's doing all the work. Step label, let me draw that over here, just put that over here so we can see what it is doing. So I can, again, I've defined these labels in this macro. I've chosen a target window to execute. I've chosen a target command, and that's really all that's needed. The description comes for free. Once I choose a command, this is its little tooltip that explains what that command does. So let's just go through some of these commands here. All right, the first command that is executing is right in this macro itself. I'm executing it here, and it's a rather complicated command because it's a logical command, and the macro is going to, it says if order RPM is not equal to 2,000, then go to 4,000. So what this thing is doing is jumping the first order, then the second order, or to the third order. So we saw that up here, those were hotkeys where I can select first, second, or third order OD and animate it. We didn't try the third order. We could go back, but we tried the first and the second hotkey, and those, really all those hotkeys do was set the RPM either to 2,000, to 4,000, or to 6,000. We saw that in the macro that for the first order. So let's assume it came in here and it is equal to 2,000. That means it's going to come in here and execute this next step. All right, it's going to go get some data in a shape table, and the shape table is called Unbalanced 2,000 RPM. And it's going to select the shape in that shape table. Which shape? Shape number 1. Unselect everything and select shape number 1. Let's go look at that shape table. Unbalanced 2,000 RPM. So here is the shape table. This is the ODS data down here. Up above are the different cases. So baseline, it's going to select the first shape in here, which is the baseline, and then it's going to, let me put this one down. So that's what that's doing. Now in another shape table called the baseline shape, it's going to unselect all the shapes. So let's go look at the shape table called baseline. Here it is. This is the one it's going to use for animation. Here you can see that it's got a baseline shape stored in there, 2,000 RPM, and here's the ODS data down below here. So this is the data that was taken from the 6 accelerometers. You can see triaxial 1, 2, 3, 4, and then uniaxial at 5 and 6. Let's blow that up a little bit. So this is the ODS data that we're using in animation, complex ODS shape data with magnitude and phase. Okay, so now it's going to go back to the Unbalanced 2000 and copy those shapes. This is a standard MeScope edit command from the edit menu. Copy the shapes to a file. Down here are the parameters. Where is it going to copy it? It's going to copy that first shape, which is the balance case or the baseline case, into the baseline shape table, and it's going to replace the data that's in there. Now it's going to go back to the Unbalanced 2,000 RPM shape table, and it's going to select a different shape. Now here it's using a variable, so it's going to use the Unbalanced Case as the variable. And what are the variables? Well, we got a whole bunch of different, which ODS, Unbalanced Case, and orders, and archive data, these are the variables that it can use. So that variable, whatever that variable is set to, the unbalanced case, it's going to select that shape. Well, let's go look at one of these unbalanced macros. Let's go to both. I'm going to open that one because we looked at that animation. So what that's saying is set the unbalanced case equal to 6. And that's what the parameters down here are doing. So when I press that macro for that particular case, both at 0 degrees, it comes in here and it's this macro. It sets the unbalanced case, and then it calls unbalanced cases, which is the macro we're looking at. That's this one right here. So you can see that it's going to select that unbalanced case from the all 7 unbalances. It's going to take number 6, and it's going to, this is the unbalanced shape table. This is where it's going to select none, and then it's going to copy from the 1 balance and the 7 unbalance. It's going to copy that one into the unbalance because that number 6 has been selected, and it's going to put it in there. Now when it gets down to here, it says go to step equal or named continue. So where is that? So now it's loaded up 2 shape tables, one called baseline and the other called unbalanced. And now it's going to come down here. Paste macro variable to objects parameter. Now it's going to paste the order RPM, and in this case it is 2000. The order RPM, let's just assume that it's running the first order. And that goes into the model, the STR or the structure window. It's pasting that in there, and then it's going to start the comparison animation. Okay, so this unbalanced machine comparison structure, this is actually not correct. This should be the unbalanced machine. And the baseline is on the left. We call that the animation source. The comparison source is the unbalanced shape. So this is what starts the animation right here. And then we set up the scaling. This is another animation command where we compare shapes relative to the left. So this is setting the scaling of the right relative to the left. This is setting an amplitude. Window position, this is positioning which window. Well, this is, again, this should be not the Mechanicom machine, but this should be I don't see it in here. This should be the unbalanced machine. And then down here, arrange windows, arrange for animation. We know what that does. That simply puts the 2 shape tables on the left and the structure window on the right. And then this is the archiving part where we're not archiving data, and we come down here and we just say exit macro. Because here it says if we're not archiving, then just go to the exit. So this one says if archive data is not equal to 1, then go to exit. And exit is down here at the bottom. So I'll leave this up for a second, and let's go back here and just press the start over. So that's going to come through here and execute that. that macro, so that is running the macro, and I can press any one of these unbalanced cases, and that's going to switch to that unbalanced case. So you can see down here, here's the case that we're animating, large inboard. The STI value, the shape difference indicator, saying those shapes are very different. If they were the same, it would be a value of 1. Let's go and say, look at the second order. So this is taking the 4,000 RPM data and doing the same thing with it. So you can see up here the baseline is now 4,000. The large inboard is at essentially 4,000, 3990, and you can see that the second order ODSs are indicating the large unbalance also. If I go to the third order, let's take a look at that one. So this is showing that it doesn't matter which order we use, the unbalance of the large inboard is at 6,000 RPM versus the baseline. It's quite different. You can see the machine moving around quite a bit here. Let's go to the worst case again, the 0 degrees of unbalance with the third order. Again, STI is very low. Now the machine is really moving around with the third order, and you can kind of see all that happening here versus the balanced case. Let's go back to the second order. This is the worst unbalance. Again, you can see that base plate is really moving around versus the balanced case. And then if we come back to the balanced case, everything will be the same. Okay, let's press this hotkey here, which says archive in database. So this program is going to set that flag to 1 for that variable called archive in database. Let's go back and look at the global variables. Right now the archive data is set to 0. We saw in the macro that if I set it equal to 1, now it's going to put data into the database. Now, where does all that happen? Well, I have a command up here that says database connection. So this is going to connect Emiscope to the archival database. Let me just show you that command. Okay, so here it is, archive database connection, add or select a DCF. Now this DCF is a database connection file. So that has all the credentials in my Emiscope to connect up to a large SQL database. You cannot connect to these databases without the credentials. So we save them in Emiscope in something called a DCF file. We have a DCF Manager program where I can create various credentials to allow not only Emiscope but different console users to connect to the database. So if I have a lot of data in my database and I want, let's say, a consultant to look at the data, I can give him a DCF file that will allow him, even for a short period of time, to look at the data in the database. So that's all of a protection mechanism for your data. Okay, so now I'm connected to the archival database, and it's telling me that this is a local database. So this is a database right here on my computer where Emiscope will archive. Now what it's done is it's opened something called a machine setup. This is where we define all the data that Emiscope will put into this database. You can see here the machine name is Big Rotor. We've seen that in the hotkey definition, because the hotkeys now are going to be shared with the console program through the database. My structure model is something called Unbalanced Machine. my monitored shape table. This is where we have gauges and warning levels and so forth. We're going to push the unbalanced shape data into the database. We're also going to use that same data to animate the machine model in console, exactly the way it's being done right here. Now the other things that we can put in here are data blocks 1, 2, and 3. These can be time or frequency data. But this is all set up, and over here it says that this machine with these different MeScope data files, an STR and SHP, is already defined in the database. It says it's in there and it's good. So this is how we define this machine in the database. I'm going to go ahead and press the archive in database. That's going to run this little macro here, and now presumably I've got data in my database. I'm going to just put this down for a minute, and I'm going to start the console. So here's the console program. Let's make this large. Oh, I need to select the database. So first thing I need to do with console is connect to my local database. I'll go ahead and do that, and you can see that we've got a connection, and it's loading up some data. So let me go back here to what we call the machine gallery. These are all the machines that are in my database, and I want to look at this big rotor, and it says it's offline because MeScope hasn't started to put data into the database yet. So I'm going to double click on this, and there's my machine model. Now it's animating with some data. I'm going to go ahead and tell it to, over here, update the baseline, and we'll see what happens here. Okay, well, let's just put this down for a minute. And what I want to bring up here, you can see this is a trend plot. These are gauges. This is what's called an event log down here. And in the event log, let me show you that I've defined a number of ODSs that have been put into the database already. And I've identified them. These are operator events where I define third order, second order, first order, and the various unbalanced cases, 1 through 8. So I've already identified that data in the database, and up here under Hotkeys are the same hotkeys that were defined in MeScope for this particular machine. So now I can remotely control MeScope by pressing hotkeys, which will execute those commands in MeScope. So let me just press this one right here. Here is a little bit of a feedback window showing me what MeScope is doing. So it says archived by MeScope, second order, case number 1. Let's go back and go first order, and that little message should change. Okay, MeScope just put the first order in, case number 1, which is the balanced case. That's the one I want for my baseline. Okay, well, I'm not quite set up here for the animation, so let's put that down, and we need to set up the comparison and so forth. I'm going to go back here, and let's just look at the trend plot here for a minute, because we're going to get data coming in. Well, this is the RPM of the machine. It was at 4,000 and it dropped down to 2,000. Let's just look at some of the data coming in from MeScope. So I'm going to go to plot selection here, and I'm going to just turn on some of the vibration data, and we'll turn off the frequency. Okay, so now we're looking at the, let's just look at the two bearings, 1 and 2. Remember, 1 was the bearing on the outside. Let me go back here and we'll put the labels up here. Labels. So bearing number 1 was the outside bearing, and here's bearing 2, the inside bearing. Animation isn't quite set up properly in here. I think amplitude needs to be much less. 0.3, and the speed needs to be quite a bit higher. Just to get it to animate the way MeScope was animating. And then I can go back to a comparison display. And there it is. So there's my baseline animating both. And over here is the SDI value. So I've got baseline left and right. I also have a Mac value up here. I can turn that off. And we'll just look at SDI here for a minute. So here it is in console, the same data. Now if I go back and press a hotkey, let's look at the worst case here again, number 6, and see what happens. Okay, you can see SDI dropped way down and the animation went way up, and this icon turned red because those values are exceeding some warning levels that I've set up in here. So you can see how this is doing very much the same thing, but it's using the macros in MeScope, and you can see MeScope sent a little message that said, I'm animating the first order case number 6. That was all in that macro that I set up in MeScope to broadcast this little message over to console. So each machine can be set up with its own macros, its own hotkeys, and you can see how this is very useful for remotely controlling the entire process from this other program. I'm going to go back here now to the home, and I want to open up something called Fax. Now Fax is an extension of this SDI calculation where we now search the database for stored ODSs that are in the database, and you can see that this fax bar has a value of 1 because this particular ODS, that being the first order, you can see it up on the top there, first order case number 6, it correlated exactly with something that was already in the database, which I had identified as first order case number 6. Here's the correlation with first order case number 5, only 73% the same. These are SDI values. So it's saying that of the data that you've already identified for this machine, here's case number 7, it's only 68% like that. So it orders the top 10 SDI values, or in this case we call them the correlation, fax correlation tool, fax value. In this case, the first order, case number 4, is only 40%, and then as it goes down here, you can see that it's getting much lower values. Case number 1, which is the balanced case, it's only 0.2%. It's not at all like, there's case number 5, very low. This unbalanced does not correlate well with any of these other cases. Let me try another hotkey. Let's go here and press, we can press any one of them. Here, number 4, large inboard. So the first feedback we're going to get is right here, first order case number 4. MeScope has told us that that's the case that got pushed into the database. Fax has identified first order case number 4 as correlating with data already in the database. It only 86% with case number 8, and there's case number 7, 82%. So you can see that these other shapes for case number 4, they correlate pretty well, but they're all below 90%. So a rule of thumb is if it's below 90% with SDI, then it's really a different ODS. So what we're doing is using ODSs and the fax calculation to search a database, and this whole process is under the control in this console. I can go to second order. That's going to send a message back to MeScope through the database, and now it's MeScope is saying, okay, I logged second order case number 4, and there it is. Fax has identified it by comparing SDI values with the values in its database. I can always go back to the model here, and it's showing, again, this is comparing the baseline with case number 4, second order, and it doesn't correlate very well. The baseline doesn't correlate, but you can see the gauges are all within their warning levels, whatever they were set up to be. We're not going to go into all that, but you can see how the macros are used to remotely control MeScope. We'll do one more case here, and then we'll go back and look at fax. Oh, here's a third order case number 4, very low SDI value. Let's put this down and go back to the fax. There we go. So again, third order case number 4 was clearly identified. The next closest case was third order case number 7, 76%. And then all these other cases are quite different. All right, well that concludes my presentation. Mark, do we have any questions?
We don't have any questions. Let me go ahead and unmute our guests and see if we have any questions there. Philippe and Reza, do you guys have any questions? We did record this presentation, so we'll be getting it up on our website here in a couple days. You can go to the Vibrant YouTube page and view it there. And we'll also have a link off of the Vibrant web page as well, our homepage. And if you have any questions after the presentation, feel free to email myself or Mark Richardson, mark.richardson@vibetech.com.
All right, I guess we'll wrap it up for this month. And we don't have a topic for next month yet, but if you get newsletters from Vibrant, or if you don't, you could certainly email and ask to be put on our newsletter list, and we'll send you the newsletter with the announcement of next month's webinar. So we'll see you soon. Thank you for attending.